In this session, we will discuss about Kubernetes controllers because we are dealing with scalable applications today. They are the actual brains behind that. So let's first see today's agenda. So we would be discussing about deploying high available applications. We would see how do we exploit the feature of Kubernetes controllers to have a highly available application running in a Kubernetes cluster. We would learn about replica set and deployment. So deployment can do a lot of different varieties of things for us. We would learn how to roll out a new feature using the deployment. We would learn how to roll back to a previous version of the software using deployment. And we would scale as well. You can scale the deployment. That means I'm running one container now and I want the container or the application to scale across in 10 containers. With a single command, you would do that. So we would learn that as well. And then we would understand what exactly a blue-green deployment means. And then we would learn how to automatically scale depending on few of the conditions like CPU or resource utilization, let it be memory utilization, any utilization. Depending on that, the conditions which you specify, we can scale in an automated fashion. And at the end, we are talking about applications and scaling of applications. And when our applications scale, we would need resources in the cluster to host them. So we would also see how does our autoscaling on the cluster level looks like. So this is today's agenda. So to start with, we would first understand what exactly is a pod and then go to the deployment. So in the last session, we understood that pod is the smallest unit. Inside that, you can have a single container or you can have multiple containers running. But we would run multiple containers when they are tightly coupled, like if they have to share an IP address or if they are bound to share a drive. In that case, you keep them together. Like, for example, you have the lamp or the lamp stack that would be spin in various containers in a pod. I would have my SQL, my Apache and all that running, PHP and all that running, and that would be running in separate containers, but that would be running in a single pod. Why we do that? Because again, coming back from the monolithic to the microservices world, in monolithic, the applications, all the services were sitting together. And if I want to scale my front end, my backend was bound to scale because they were sitting together, right? So we started to work with microservices in which we are breaking the services of front end and back end in the middle, where middle tier in different services. And if I just want to scale my front end because there is a lot of traffic coming to my website, I can only scale my front end without affecting the back end. So in such cases, I can scale only the containers or the pods which are serving the front end. So in those cases, this comes in pretty handy. This feature is cool. That helps us in doing that. And we normally use pod to say that pod is equivalent to a container or pod is equivalent to a bunch of containers which are working together. When they are sitting in a single container, they are having their life cycle tied up together. So I would show you that we can spin a pod using a command line from a command on our command line interface in our cluster. And if something happens to the pod, no one is there to take care of it. We, being the cluster administrator, would have to spin up the pod again. So let me take you to my cluster. I have reduced the nodes in my cluster. I'm using the same cluster even today, but I've reduced the number of nodes because I have to show the auto scaling and all that features. So I have the cluster with a single node at this point of time, and I want to create a pod. So kubectl run command is the command to create any type of resource, a running resource. And you can specify what type of resource you want to create. So generator -pod says that I want to create pod. And pod belongs to version 1 in Kubernetes. So I specify that as well. I want to create an Nginx pod. I will say Nginx CMD, and I want to use image Nginx. So with this, I can create a pod. So if I execute this command, this would create a pod. So let's go ahead and check whether our pod got created. The get command gets us the resources which are running. So I'm saying get pod. So now my pod is up and running. It is an Nginx pod. And how do we know whether it has a container, not has a container? You can always go and describe any of the resources which you create. So describe, I want to describe. So kubectl is the command line thing. Then describe is the verb we want to do, the action we want to do. The type of the resource is pod, and the name of the resource is Nginx. Sorry, my bad. The paste didn't work properly. I'll type in the name. Nginx CMD is the name of the pod. So here I'm trying to describe the resource which I've created. So if you go and check over here, it's created in the default namespace. It is created on this node. The label is Nginx-CMD. This is the IP address. The state is running. And this is the container. And there is the container ID, the image is given, the image ID is given. In case we would have mapped any ports, opened any ports, it would have shown over there. The container is up and running. It had started at this point of time. All those descriptions about what exactly is running inside this pod is mentioned. In case I have multiple containers inside this pod, in this section, you would have 2 containers just mentioned over here. So now if I go and kill this pod, kubectl delete pod Nginx-CMD, the pod gets deleted and no one is there to really check whether the pod is up and running. Here I have manually deleted it. It could be that someone has accidentally deleted who doesn't know that I have created that, or because of some resource constraint or some other issue in the cluster, my pod gets deleted. It would not get recreated by itself. And that is one of the drawbacks why we say that even the containers had the drawbacks. There was no automation or the orchestration tool handling the recreation of the pods or the container. So what we do, we will go to the controllers section now, and we will see what exactly a controller means and why we need to use controller to deploy such application pods, and what is the advantages of that. So to start with, I would say the actual brain behind the Kubernetes itself, which helps them orchestrate or manage the containers running in the cluster, is the controller. These are the processes that actually monitors the resources and takes action as and when needed. Like for example, if I have created a type of resource and I say that this particular Nginx container has to be up and running at any point of time, the controller will make sure that the container of Nginx is up and running. So we would learn about replica set and deployment first, and then move to other type of controllers. So what exactly is a replica set? Let me go through the slides. This is the pod definition, which I had shown over there. So you can run through the slides when you have time and see the definition. So when we are talking about deployment, deployment actually constitutes of pod, a replica set, and a deployment. So the number of resources get created in a hierarchy, pods get created. I'm saying that I'm running a Python application in a pod and I want 3 replicas of that pod. That means the same piece of Python application would be running in 3 of the containers. So these are the 3 pods. And if the user wants to reach that, the traffic would reach 3 of the pods. But how would that be? Because the pods would have their own IP addresses, right? So that's the reason someone has to be there to distribute the traffic across the pods. Someone has to be there to make sure that all these pods are part of a single application. They are the replicas of the same application. That's the reason we create one more component called as replica set. So replica set's purpose is to maintain a stable set of replica pods running at any given time. And replica sets uses selectors like if I'm creating a pod and naming it as Nginx, I can say my replica set will point to all the pods named Nginx. So when my replicas are scaling from 1 to 3, it would have all the pods with name Nginx mapping to itself. So replica set will keep account of all the pods having the label of name Nginx. Okay, so if the replica pods have decreased, then replica set understands that, oh, I had to run three number of pods at any point of time, and now my replicas have gone down to 2. So let me spin up one more. So replica set is like a controller which is sitting and managing and making sure that desired number of containers or the pods are running at any point of time in the cluster. So we'll see the demo as well. And to wrap up this replica set, we have something called as deployment. Replica set is maintaining the number of replicas, and deployment helps us in rolling newer versions of software, rolling back and all that stuff. So let's see what exactly happens. So here we have understood the role of a replica set. Let's try and understand what exactly happens when a deployment is created. So deployment would be like a high level concept that would manage the replica set and the pods as well. Okay, so it's like in hierarchy. Deployment is managing the replica set is managing the pods, and pods are in turn having those containers. So deployment provides a declarative update for any pod or replica set. So in the deployment definition file like this, we would create a file like this. In this file, we would say that what type of resource I want to create, how many replicas of that resource I want to create. And nowhere you would see the replica set mentioned over here. When we are creating a kind, I had mentioned in the last session as well, when I'm saying kind, it's a type of a resource I wish to create in the cluster. So I'm saying create deployment. That means it would in turn create a replica set, and it would take up the pod definition and create a container inside that. So let's see what exactly is mentioned in the deployment definition file. This is the version of the deployment was introduced in Kubernetes. You can't remember this, so obviously you will have to refer in which version the deployment was introduced. The kind is deployment. There is a metadata about the deployment. I have named the deployment as Nginx deployment. I have labeled it as app Nginx. And why labels are used? Because when we have to make sure that deployment is pointing to a correct replica set is pointing to a correct pod, they use these labels and selectors. So in the specification section, so this is the specification for the deployment. I'm saying that I want 2 replicas, but of what? That would come later in this section. And it's saying that I'm selecting any resource which has label as app Nginx. And then the section of pod starts. If you see the template is the one which is actually the pod definition. And that pod has a metadata. It has a label app Nginx. So my deployment is mapping this selector to this label. And there is a specification of the containers mentioned over there, and the name is Nginx. Image taken is 1.16 Nginx, and the port number opened in the container is port 80. That means I'll spin up a container which would have an Nginx image, wrap it up with a pod. It would have replica set. So replica set would say that I would run 2 pods of this type, and I would have a deployment as well. So let's go ahead and check how does this happen. So I have written the same file over here. The same file is over here. So I'll just quit and I'll create the resource. To create any resource in a Kubernetes cluster using a file, the command is kubectl create -f stands for the file, and you give the file name. So I'm saying using this file, create the resource. So whatever kind is mentioned in this particular file, that particular resource creation would happen. So you would have kubectl get deployment. You can write the short form as well. So I'm trying to see whether the deployment got created. If you see here, it says Nginx deployment got created. 2 bar 2 means 2 is expected, 2 is ready. 2 are up to date and 2 are available. That 2 counts for the number of replicas which we had mentioned inside the uh, deployment definition file. So let's go ahead and check our pod status. There should be 2 pods which should be up and running. So here 2 pods are up and running and they should belong to a replica set. So let's see whether we have a replica set. To see all the resources what is actually present in this cluster, you can do kubectl get all command. I have run this command at this point of time. It's listing both the pods, it's listing the deployment, and it's listing the replica set. You never specified a kind replica set. We had specified the kind deployment. It has in turn created kind replica set. Here, if you see, it says the desired count is 2, the current count is 2, and the ready count is 2. That means 2 are up and running and they are in ready state. They are working fine. So this is how we create a deployment. Now, when I had created a pod and I tried to delete it, no one tried to recreate it because there was no controller sitting and monitoring and was maintaining the desired number of pods running, right? So now what would I do? I would try and kill one of the pods and see whether the replica set does its work of maintaining 2 Nginx pods up and running at any point of time in the cluster. So let's go ahead and delete a pod. So it's always kubectl with the action you want to do on the type of resource and the resource name. Let me delete this particular pod. So the pod is deleted. Let's go and check. If you see, I had deleted 76RHK, immediately a different pod has come. H5J6H was already existing. This is the new pod which has come. It has spin up 8 seconds ago. So what happened now, anytime our Nginx pod is going down, someone is sitting there and monitoring it and making sure that the replicas of the pods are up and running and our service is not down. So replica set makes sure that the pods are up and running. So that is the functionality of replica set. Hopes that clear. I'll take up any questions if they are coming. So there was a question, will we have the commands of this session? So the complete video of this session would be shared on YouTube. You can go back and refer to that. In case you want the commands handy, I can post it in our GitHub account and share the link as well. I would do that. So hope so you understand the functionality of a replica set. Now let's go ahead and understand the functionality of deployment. So to do that, let me see which image this deployment is running with, right? So any of the resource which is running, I can do a describe on that. So I'll do kubectl describe. And what I want to describe, I want to describe a deployment. And I'll copy this because it has both. So deployment is the type and / is the name of the deployment. So here, if you see, the image is 1.16. So I would go ahead and change the image with which my container is running. I want to upgrade my Nginx pods with 1.17 Nginx image. So what I would do, you can use command line. I'll show you 2-3 ways of doing that. We have a file of a deployment. So there are 3 ways of doing this. One is you have this file, which is the Nginx deployment file. Because our resource is running from here, and most of the time these are the files which are maintained in a code repositories, right? So you would be pushing this file to our GitHub or any code repository you're using. So what I would do, I would go to 1.16 and let me change to 1.17. So this is changed in the file. It's not reflected to the running resource. My deployment is still thinking that it is 1.16. So I would have to apply the file changes to the running resource. So for that, what you would do kubectl apply and apply what? The changes of this file. So I would give the file name, and I would say whatever changes are there in this file, please apply to that. So what would happen now? I would do kubectl get all and show you that one more replica set gets created. This is the newer replica set. This is the older replica set. Deployment understands that now two pods of newer versions have to run, and the two pods of older versions have to get killed. So it would create a newer replica set, create two pods in that replica set, and those would be up and running. So let's see whether our two containers are up and running. These are the two newer pods which are up and running. So let me show this in the slide format so that you understand. So this was my old replica set, which was serving. So this was my deployment, my replica set, my user was reaching it. I create 3 pods inside a replica set of version 2, and both the replica sets are up and running at one point of time, but my traffic is always going to version 1 unless and until my version 2 is stable. And how do you make sure your version 2 is stable? There is a timer mentioned in the deployment, which is by default 60 seconds. And in case the 60-second timers expire and our containers are up and running, Kubernetes checks the status of the containers. If they are up and running, they are looking fine, it would switch the traffic to the version 2 and slowly delete the version 1 containers, and the replica set would be marked 000. That's what you had seen. Here, replica set is still existing, but it says desired is 0, current is 0, ready is 0, and in the newer replica sets, there are desired 2, current 2, and running 2. And here, the deployment remains the same, but newer pods gets created, which are serving 1.17. So let's describe our pod, describe our deployment and see whether it is really having 1.17 image now. Yes, the changes have reflected and it has 1.17 now. So what has happened? If you want to see any of the logs on the deployment, what has happened, this is the best place to look for any of the things. This is the events place. Here you can see the scale up, scale down, scale up, scale down. Every log related to this deployment would come over here. This is one of the place to see any of the things. Or on a cluster level, if you want to see, you can do get events on the cluster. But one thing is, this is not sorted according to the timestamp. So you would have to sort it according to the timestamp and then refer to it, or grep for any specific resource over here. Okay, so here what I did, I have changed the image name from 1.16 to 1.17. That means I'm referring to a different image altogether. My pods of older versions still remain serving the traffic. First newer pod came and they came up and running. They were stable, but the traffic was not routed to that. Once the 60-second timer is out, my traffic would switch to that and my version 1 pods went down. And that is how it happens. So here it would not bring back, in case there is something wrong, you can roll back as well. We would see that as well. So before to that, I will show how to scale it. So in case scaling, now I'm running 3 pods of Nginx type, right? Nginx 1.17. I want to scale one more. That means the traffic was too much. I think that now I should run 4 pods of Nginx type. So what I would do, I would scale to 4, and then the traffic starts flowing to that as well. And we would discuss about networking in one of the sessions. Then you would understand how this mapping happens, how the traffic starts flowing to that. But for now, understands that this pod belongs to that replica set. Whenever you're scaling, the replica set understands now I should maintain 4 of them instead of 3. So let's go and check in our command line how to do that. So there is a command called as kubectl scale. What do you want to scale? You want to scale the deployment. So you would give the deployment. What is the name of the deployment? Nginx hyphen deployment, and I want to scale to replicas equal to 5, for example. So now what it would do, it would scale number of replicas to 5. Then I'll show you the deployment definition file, and why this is not responding. Let me check 1 second. kubectl get all. Let's see whether the connection to my cluster is lost, I think. Just give me a second. Let me check whether my nodes are up and running. I'm unable to reach the cluster. Okay, awesome. I could reach that. Okay, so there was a delay latency in the network. I think that's the reason it didn't. So I think this command didn't run. So the name of the deployment was deployment. So let's do that. Yes, it has scaled to 5. So now we should have 5 replicas. You would see that immediately 3 more pods running in Nginx has spun up, and our replica set is reflected to maintain 5 as the desired count, and deployment also understands that it should have 5 replicas up and running. And I did it from the command line, but if you go ahead and describe your deployment, you would see that the replica stuff would have updated with 5 now. So whenever you are changing from the command line, or you're making changes in the file, or you're applying the file changes, it would reflect on the running resource. So last time I made the image change from the command file and applied the file changes. Here now I had just updated a running resource, but if you see the file, here I have not changed the file, right? So here the file would say replica is 2, but I have explicitly gone and made the number of replicas on the command line to change to 5. So now you have 5 pods of Nginx up and running. So this is the command to scale. I want to scale down, I can do that. You can scale to 1, and it would go ahead and kill the number of pods, 4 of them, and it would reflect that in the replica set and deployment both. Hope this is clear. Let me check if there are any questions. If one of the pod goes down due to the node becoming down, suppose the same node comes back, this the pod will be restarted on the same node. Okay, so here the pod goes down because the node has gone down, right? So it would take some time for the node to come up because it's a virtual machine. Before that itself, my controller would sense that pod has gone down, and it would controller sends an update to API server. API server goes and checks with the scheduler that which is the best fit node now to spin up that pod. And what would happen, because that particular node is down, it would not be considered as the best fit node because it is not functioning at this point of time. And with rest of the nodes, whichever node is the best fit node, the pod would immediately come up there. It will not wait for the pod to the node to come up and then to spin the pod, because if that way we are going to wait, we would be spending 2 to 3 minutes in bringing up our virtual machine and making it up and running, right? So that we would not do. Okay, so this is how you scale. So you can scale down as well, and it would stop sending the traffic to that. Now let's see how to roll back. You had been using version 2 now. I want to roll back to version 1. I'm not happy with version 2. I'm not getting good reviews with version 2 with my customers. So I want to go back to version 1. So how do I do that? So you can see the rollout histories of your deployment. So command is kubectl rollout, and you check the history and give the name of the deployment. So it will show that there are 2 changes. You could have given -- record and given a name for that rolling out process when we changed from 1.16 to 1.17 and all. Then I would have got any comment over here. I would have seen a comment over there. But because I have not mentioned any comment over there, I don't see. So my version 1 is 1.16 and the revision 2 is 1.17. I want to go back to revision 1. So what I would do, so I would say that kubectl rollout, I would undo, but undo what? Undo this deployment to what? --2 revision equals to 1. So I'm saying go back to revision 1. So normally what happens, I can store like this 50 versions of my deployment, and suppose for example I'm running some version 49 at this point of time and revision 49, and a field issue or a customer issue has come in revision 2, I can immediately roll back to revision 2 without wasting any time. Within fraction of seconds my revision 2 pods would be up and running and revision 49 pod would be killed. So here you would see that it would have terminated because I'm running just one replica. That pod is killed, and pod of 1.16 should be up and running because I have rolled back to 1.16. So let's describe the deployment and check whether I'm on 1.16 image or not. Yes, awesome. So we have rolled back from 1.17 to 1.16 again. Hope that's clear and we understand what's the functionality of a deployment and a replica set here. So this is how you do. I've shown the demo. So any questions on deployment or replica set at this point of time, I would address so that we can go ahead with auto scaling part of the application. I'd also mentioned, sorry, I forgot to mention about the types of deployment. I was mentioning that we can do blue-green deployment, we can do canary deployment. So using deployment, we can do blue-green deployment. I can have a few pods of version 1, few pods of version 2 also functioning at the same point of time, and I can say 10% of the traffic should go to version 1, 10%, 90% of the traffic should go to version 2. I can do that. That is like a canary deployment. I would be covering the different types of deployment in a few of the series with webinars which would be coming, upcoming webinars. And we can also, the type of deployment which we did now is like a blue-green deployment. We had a blue deployment, which is the version 1. We made a green deployment, which is the version 2, and we did a switch from version 1 to version 2. At no point of time, my customer could see few customers seeing version 1, version 2. That is not the case. I switched from version 1 to version 2 in a single click. That means that the complete traffic switches from version 1 to version 2. Or it rolls back from version 2 to version 1, however I'm switching. So this is like a blue-green deployment. I can even do a canary deployment with this. So this is the deployment part of it. So let's go to auto scaling because I don't see any of the questions pouring in. So HPA means horizontal pod autoscaler. Now, with deployment, I had typed in a command to scale, saying scale to -- replica 5, -- replica 10, -- replica 1. I could scale up and scale down on demand from the command line. Someone is needed to do that. But if I want to do it in an automated fashion, like for example, I am running a taxi booking software, my website books taxi. So every day in the peak hour time, I would have a lot of traffic on my website. And when it's like non-peak hours, daytime, 12 a.m., 12 p.m., 1 p.m., there's not much of traffic, right? So at that point of time, the number of pods serving the website should be less. And at 5 o'clock to 9 o'clock, when there is a peak traffic, office hours is ending and people are going back home, I should have more number of pods serving the website. So in that case, depending on the demand of the website, the traffic coming to the website, I should be able to scale up. So how do we do that? So normally in our nodes, these are the nodes. And in those nodes, there is something called as metrics server. There is a metrics server pod running in one of our nodes. And every node has kubelet, which has something called a C advisor within that itself. So when we installed our Kubernetes cluster or created our Kubernetes cluster, our kubelet agent came up and running. C advisor was part of it. What's the work of the C advisor? C advisor's part is to read the CPU memory utilization on the container level from the node and provide it to the metric server. So what it would do, it would pick up the details of the CPU memory and all that and provide the details uh, to the metric server. And from there, the metric server should take a decision whether how much is the traffic running and all that, right? So here metric server is the component which is collecting information from the cluster all around the cluster. Let it be an Nginx pod, let it be a SQL pod, let it be a Redis pod, anything running. So metric server is something which is used for collecting the metrics. It is collecting the metrics with the help of C advisor. So from every pod, it is collecting metrics, combining them together to make it node specific numbers as well, pod specific numbers, container specific numbers, all the numbers are collected. And then these metric servers sends the report to something called as HPA, which is the horizontal pod autoscaler. We would create a component specifically for this deployment. I would say that this deployment should autoscale itself depending on some condition. And how do I collect those metrics? Metric server is providing me those metrics, and depending on the metrics provided, HPA would again go back and talk to the deployment, change the number over there. We manually changed the number of replicas to 4 or 5 this time, right? Now HPA would automatically change the number. The number would be reflected in replica set, and that is how the pod would get created and the traffic would start flowing. So let's see how that happens. So here, there is a difference. Last time when I created a deployment, I never mentioned what is the resource used by my containers. I didn't give any limiting resources. So what would happen? My container could utilize the max optimum utilization, whatever is defined for the any pod in Kubernetes. So here, to create a HPA, we should know what exactly is my container's requested resources, because unless and until I specify the request, I can't say on what conditions to scale up, right? For example, if I have a 2 GB RAM and I say that if my memory is 80% occupied, then scale and make it a 4 GB RAM or whatever it is, right? 8 GB RAM. So if I specify a number, depending on that, I can specify the percentage on that. So what I would do, we would have the limit resources mentioned. Here, limit is something and request is something. Request is the initial amount of resources needed for the containers, and limit is the max limit it can go up to in this particular cluster for this particular pod. So let's see, how do we create that? We would create a horizontal pod autoscaler component here, and we would scale that. So let's first create a deployment which will have the resources configured. So I have written an Nginx HPA file over here, And this is the same file which I showed you on the slide. This is the resources. So here again, I'm creating an Nginx pod, but this time I'm limiting the resources. So command is again the kubectl create -f Nginx HPA, and this would create a deployment or replica set in a pod. So let's do kubectl get all because it is creating a lot of resources. So here HPA pod is under creation. You have the replica set for HPA, you have the deployment for HPA. So my container is happy up and running at this point of time. But how do I scale automatically? For that, we would create a resource called as horizontal pod autoscaler. And before to that, let's see how do we check what is the resource utilization on or pods or nodes. You can do top command. So at this point of time, the Nginx deployment pod is showing 0 minutes. Get pods. Let me see whether that HPA pod is running. Awesome. The HPA pod is also up and running. So that would get listed here. Top command is not showing that particular pod at this point of time because metrics server would go and collect information in some time interval, and it has not collected that particular pod's information at this point of time. That's the reason our pod is not listed here. Now that went collected, and now you have the results listed here. At this point of time, there is no CPU utilization and all at this on this particular pod. So let's do what? Let's create a autoscaler component, kubectl autoscale, and I would say autoscale what? A deployment, and I would give the name of the deployment Nginx HPA if I am not wrong. Yes. And I would give the minimum number of pods. The minimum is it should scale down. If the percentage of utilization goes very less, it should at least maintain 1 pod, and max it should go to 5. And on what condition? I'm saying when the CPU percentage, because if I give a high percentage, I can't scale up because I have to create that much of load on the traffic. That's the reason I'm giving a very small percentage of 1. So if my CPU utilization is going beyond 1%, my number of replicas of the pod should auto scale here. So let's create this and see whether autoscaler, here you see here autoscaler gets created. So you can kubectl get HPA. So here it has got created, the HPA is created, minimum pod is 1, max pod is 5, and the utilization percentage is 1. So what I would do, I would create one more tab, and here I would go inside the pod. What's the pod name? This is the pod name. I would try to overload the pod. Let me go inside the pod and run an infinite while loop. So while true, do true, and done. So this is an infinite while loop which I am running. When I do this, there would be an increase in the resource utilization on that particular pod, and that would take some time to reflect. And after that, you would see that the pods are auto scaling. And it would go maximum up to 5 pods. So it would take some time. Let's give it a few minutes, so that a few seconds, rather I would say a minute, sorry. It would take some time to reflect because there it is mounting, depending, it starts hogging the CPU, the infinite while loop, and it would take a bit of time to reflect. Here you see 3 millicores utilization has reached. Now if you go and do get pods, you should see containers spinning up. So here there are 4 HPA contain pods running at this point of time. So it will go max up to 5. It will not go beyond 5. Even the resource utilization goes more, it would not scale more than 5, because we have mentioned that 5 is the maximum number of pods with which we should be always there at any point of time in case we are scaling as well. So this is how it auto scales themselves. And for doing this auto scaling, we created a different type of resource called as horizontal pod autoscaler. You can get HPA, you can describe this HPA, and you can see that HPA resource got created. It's like a deployment. You're creating another controller calling HPA. It collects the metrics from the metric server, takes an action depending on the definition or the conditions you have specified. So this is on the application autoscaling. Hope that this particular thing is clear, the HPA and all. So let me see if there are any questions. So what is the part before deployment.apps? So whenever we are running any command, deployment.apps is the type of the resource, the kind of the resource we created was deployment, and then the deployment name. So here deployment and the name of the deployment is Nginx HPA. So that was one of the questions. So I picked up. Now I want to show you cluster autoscaling. So at this point of time, I have only one node in my cluster. Let me take you to my cluster. So here I have just one node. You can go to this pool and you can go to resize. Here I had mentioned there is a fixed size of the cluster. You do a auto scale, and I say that minimum one node, maximum two node you can auto scale up to. Do a save over here, and in case there is a load on one of the nodes so much that it needs another node to be spin up, it would do that. So let's go ahead and try and scale that. So scaling this would be difficult, the HPA one. So what I would do, I would go ahead and scale the command line one. Okay, so kubectl scale and scale deployment. I would scale this deployment, Nginx deployment, and I would say hyphen replicas is equal to 200, for example. So what would happen at this point of time in this particular cluster, I just have a single node, and you can even do kubectl top nodes. It will show you the resource utilization on that node. And because I have mentioned the number of pods to be scaled to 200, if you see now here, containers have started creating, but they have gone to pending because on the single node, I don't have that much of resource to scale to 200 pods, right? So you can even go and check get events. Let's do and see if we have any logs. Here it's trying to create, it's trying to schedule. So failing schedule, insufficient resources, all those things are there. Zero nodes are available. I don't have any resource at this point in the cluster to do that. So let's see what would happen now. Because I have mentioned auto scaling on the cluster, it would take some time and it would auto scale this cluster to 2. But that would take some amount of time because on this, here you see one more node is coming up because I had mentioned here in the section of autoscale that in case my cluster has to autoscale, scale one more node, right? So here this node is coming up. It would bring up that node, put kubectl, kubelet, put Docker and all that, make the node join the cluster, and then it would start hosting the pods on them, right? So that would take some amount of time. At this point, it has not joined the cluster. That's the reason here you're not seeing it, but on the console, you see that the cluster has really autoscaled. To do that, it would take a little bit of time, but Kubernetes is intelligent enough. The API server, the scheduler, they are intelligent enough. They know that these many pods are in pending state. And the reason for them to be in pending state is a resource crunch. As soon as there is a resource added to the cluster, you need not repeat this command. automatically scheduler starts scheduling these pods on the newer node, and you would have that. So this would take some time because we are running out of time. I think time is almost 7. Let's see if there are any questions. I can take up the questions, and parallelly we can check the status. So here the node 2 has joined, but it is not in ready state. Still it is doing the joining actions and all. So this was today's session's agenda, covering deployment, replica set, horizontal pod autoscaler, and the cluster autoscaler. Any questions? Then please ask the questions now because we are running out of time. Okay, awesome. Nodes are in ready state. Let's see the pods. So pods have from pending to it has gone to creating state.